Dear students, in this video, I will tell you about the remainder and factor theorem. What is the factor? I give you some example. If you have 6 and it is divided by 2, what you will get? 2 3s are 6 and the remainder is 0. Remainder is 0. In the second case, if 2 is there and 7 divided by 2, then you will get remainder as 1. In this case, remainder is 0 and in this case the remainder is 1. What is the difference? Can you say 2 is the factor of 7? No. But in this you can say, and you know also, 2 is the factor of 6. So this is the difference between the factor and remainder, factor theorem and remainder theorem. If you get 0 by dividing any number, so this number means divisor is a factor. But if you get other than 0, then divisor is not a factor. Based on this, I have to tell you about the remainder and factor theorem in algebra. In algebra, the same thing, when suppose we have x plus 1 is divisor and the dividend is x square plus 2x and plus minus 4. In this case, if you divide this one by x plus 1, what you will get? X into x square, x into 1 plus x, and then subtract, you will get x minus 4, again plus 1 into x and plus 1 minus, that is minus 5. This is the first example and the remainder is minus 5. Second example, when you have the x plus 1 and it is x square plus 2x plus 1. So when you divide this by x plus 1, you will get plus x minus x plus 1, then plus 1, x plus 1, and in this case the remainder is 0. It means x plus 1 is not a factor of this, because remainder is not 0, means minus 5. But here x plus 1 is a factor of this because remainder is 0. So this is the difference in the remainder and the factor theorem. Now how to do? By using the remainder and factor theorem, will not use the long division method, will use without actual division, we can find also the remainder by using the remainder and factor theorem. How it is? If you have the question, suppose x square plus 2x plus 3 is divided by x plus 1 by using remainder theorem. So what you will do in this case, you will write first of all the dividend, means this one you will write as fx is equal to x square plus 2x plus 3, and the divisor you will write as gx is equal to x plus 1. This is the equation 1 and this is equation 2. Then remainder theorem, as we know, when we divide this by this, then we get the remainder. It means you can write by remainder theorem gx is equal to 0. It means x plus 1 is equal to 0, so x is equal to minus 1. This x is equal to minus 1 you put in the equation 1. It means f of minus 1 is the remainder when we divide by x plus 1. This is the meaning. First you will let fx is equal to gx is equal to, then you will write by remainder theorem gx is equal to 0, so x plus 1 is equal to 0, so x is equal to minus 1. You will put this x in the equation number 1. It means f of minus 1 is remainder. Now x square f of minus 1 is equal to x square means minus 1 whole square plus 2x and plus 3. Then you will get minus 1 minus 2 plus 3, that is equal to plus 1. 1 minus 2 plus 3, 4 minus 2 is equal to 2. This is the remainder. Means x plus 1 is not a factor. But in other case, when you get the factor, this is without actual division. Without actual division, you will get the factor, remainder. In the second example, if x square plus 4x plus 3 divided by x plus 3, what is the remainder? Then you will let fx is equal to, as usual, 4x plus 3 and gx is equal to x plus 3. Equation number 1, equation number 2. Then by remainder theorem, gx is equal to 0. So x plus 3 is equal to 0 means x is equal to minus 3. So what is the remainder? Remainder is when you put x is equal to minus 3 here. So f of minus 3 is the remainder. Now f of minus 3 is the remainder. So f of minus 3, put the x is equal to minus 3 in this equation. First equation, minus 3 whole square plus 4 into minus 3 plus 3. This is equal to 9 minus 12 plus 3 means 12 minus 12, that is equal to 0. You can see the remainder is 0. Remainder is 0, it means the x plus 3 is a factor. Now, so x plus 3 is a factor. If remainder you are getting 0 in any case, it means the divisor is a factor. If remainder is not 0, then that divisor is not a factor. Also in the second thing, that is the when in any question it is given that gx, in any question it is given x plus a is a factor of fx. It means that x is equal to minus a when you put, though f of minus a will be 0 because it is a factor. So f of minus a will be 0 because it is a factor. Directly you can take by your own, that is f of minus a is equal to 0. From where minus a came? As I told you in the previous example, when any polynomial which divide the other polynomial, that polynomial you will take is equal to 0, x plus a is equal to 0, so x is equal to minus a. That minus a you will put in fx, so f of minus a is the remainder. But here it is a factor, therefore the remainder is 0. So f of minus a is equal to 0. Now one more example I will tell you that which explain the remainder and factor theorem. If the polynomials fx is equal to 2x cube plus ax square plus 3x minus 5 and gx is equal to x cube plus x square minus 2x plus a divided, leave the same remainder, then when divided by x minus 2, find a and the remainder in each case. So how to find? In this case, if you read the question again, there are two polynomials and both the polynomials when divided by x minus 2 leave the same remainder. Same remainder means the f of x minus 2 is equal to 0. So x is equal to 2. So f of 2 and g of 2 both are same. Both leaves the same remainder. So when you put the value f of 2, x is equal to 2 here and x is equal to 2 here, in the next step you will take equal both the equations. Then you will get the value of a. Now by remainder theorem, x minus 2 is equal to 0. So x is equal to 2. So f of 2 is remainder and f of 2 is equal to 2 cube, 2 into 2 cube plus a into 2 square plus 3 into 2 minus 5. Then this will be 8 to the 16 plus 4a plus 6 minus 5. This is equal to 17 plus 4a. F of 2. This is f of 2. Now you have to find, this is the equation number 1. Now put again x is equal to 2 in this equation gx, because both the polynomials divide by the x minus 2. So now g of 2 is remainder when divided by x minus 2. So put the value g of 2 is equal to 2 cube plus 2 square minus 2 into 2 plus 8. So this will be 8 plus 4 minus 4 plus a. So is equal to 8 plus a. This is g2. Now according to question, because both leaves the same remainder, therefore f2 is equal to, now both leaves same remainder. So f2 is equal to g2. So 17 plus 4a is equal to 8 plus a. 4a minus a is equal to 8 minus 17. and 3a is equal to minus 9. So a is equal to minus 3. This is the value of a. Now find the remainder in each case. So you put the value of a in equation 1 and equation 2, you will get the remainder as 5. As g2 is equal to 8, a is equal to minus 3, 8 minus 3, that is 5. And in f2 also you will have the same, 17 plus 4 into minus 2, minus 3, minus 12, so 17 minus 12, that is 5. So in every case, this is the method to solve the remainder and factor theorem. Thank you.